Okie dokie. So, yesterday we looked at solving these what? Equations. What are equations?
Linear equations.
They're linear equations, so what are linear equations?
System.
Good! Because I have this grouping there. It's a system of linear equations. So yesterday we solved them by graphing, and I think some of you guys were a little bit above or ahead of the curve, and you start solving algebraically. We can solve this without graphing using the magic and wonder of algebra. So looking at algebra, how can we solve this system of equations?
Substitution.
Substitution. What do you mean by substitution?
Like, I would take the 4x multiplied is 5, and then I would subtract 4x to the other side, and then divide by -1 to get y by itself, and then plug y into the other equation to get x.
Okay, so what we do first, you're saying you would solve this right equation for y, so we get 4x minus 5. And then what would you do with it?
Plug it into the other equation for y.
So you would basically substitute y?
Yes.
Oh. So we get 5x minus 2 times what?
4x minus 5.
4x minus 5 equals 4. Note, I put what I was substituting inside of parentheses. That's going to be extremely, extremely helpful when you have negative signs and all sorts of stuff. So just make sure that you always put whatever you're plugging in inside of parentheses. Okie doke. So now I can simplify. So I get 5x minus 8x plus 10 equals
4.
still 4. Simplify further, combine those like terms. If I combine my like terms, what do I get?
Negative 3x plus
Negative 3x.
Equals -6.
Good, equals -6.
And you can divide that by -1.
Well, okay, so right, we combine the x's, so we get negative 3x, and all we did was we subtracted 10 from both sides of that equation, so that we get -6 over there. And now we can divide by the coefficient of x, which is -3, and we get x equals 2. Yay! Am I done?
No.
Oh, why not?
Plug it back in.
So I have to solve for y. So I take my x's 2, and I plug this back into here. So I get y is equal to 4 times 2 minus 5. So what's y equal to?
3.
8 minus 5, which is 3. Now again, what is this? Well, yes, so it's substitution of
Solving algebraically.
solving a system of linear equations. So these equations represent lines. So it's all right. So that solution. The solution is really what? A point. How do I write a point?
X, comma, y in parens.
Is that what we call it on the streets now? Parens? It's a happy face. Or, for this example, it is... It's a sad face. No. All right, for this one, it's what comma what?
2, 3.
2 comma 3.
Yeah.
Honking at the right side.
All right, so that's
Tell if
using...
they're agreeing or
Yeah.
I think they're disagreeing.
They were honking in the math class. We're like, yeah, substitution. All right, so we use substitution, right? We're solving one of these equations for a variable. Why would we... I'll hold off on that question for a minute. There is another algebraic method we can use. Elimination. Poof. So if I say elimination, what's the whole point of elimination?
You want to eliminate one of the variables from the equation.
So what's the big problem? Like if I had either of these equations on their own, I mean, what's the big problem then?
Yeah. You don't know what's equal, what either one equals to.
Okay.
They both have two variables.
Yeah, exactly, right? There are two variables in there, so we can't get an exact value. But if we substitute one in, poof, one of the variables is gone. We can also just straight up eliminate one of the variables. So here, for this example, which variable would you want to eliminate?
Why?
Why?
It's the
Maybe
easiest.
one. Eliminate X.
I just felt like saying y after you said y. Okay, so yeah, we can eliminate y. You could eliminate x if you wanted to, but as Sophie said, well, in this case, it might just be the easiest. So how would I go about eliminating the y? So I can multiply this whole bottom equation by -2, and what do I get?
8x plus 2y
Negative
equals
8x.
10. Oh, negative 8x. Not B.
Okay. So you just multiplied by a +2.
Yeah.
And we're multiplying by a -2. Both work. It's just you have to do a different operation, right?
Wait, why do you multiply by -2?
Stay tuned to find out.
Would that just be plus 2y?
Hold up. So plus 2y could equals
Oh.
-10. So, good question, right? Why did we change the value of that equation? What do we do this for? Well, what am I going to do with these two equations now?
It's add.
Add. Yes, I'm going to add these two equations. And that kind of gets back to multiplying by a 2 or the -2. You could subtract the two equations if you had multiplied the red one by +2. But since we multiplied by a -2, don't forget, addition is nothing more than, subtraction is nothing more than addition of the opposite. So all we have to do is multiply by a -2 and add them. And now, well, my y's right there in that column. What's 2y plus -2y? 0y, right? They eliminate, they cancel. -8x plus 5y is?
3. Negative 3x.
-3x equals?
Negative 6.
-6, so x equals?
2.
+2. And now that I have x, how can I find y?
Plug X in.
Plug x, doesn't matter where?
No.
So where do you want to plug it in?
Plug in. Well, as long as you plug it in where it says the number, then X.
Okay.
As long as you plug it in there.
So so Scott, which one would you like to plug it into?
Well, yeah, that wasn't a decision. I would plug it in to the 5x minus 2y.
Yippee skippy, let's do it. So we plug that in, so we get 5 times 2 minus 2y equals 4. So here we get 10 minus 2y equals 4. What can I do now?
Subtract the 10.
So I get -2y equals. So Scott, what's y equal?
Y equals 3.
And how do I write that point? The solution?
Right, that point you would go 2. Well, in parens. 2.
In parens, we're sticking with that.
3.
2 comma 3. All right, cool. We're sticking with the term parens. So do I have to eliminate the y in this scenario? No. You could eliminate the x as well. What would you multiply the red equation by?
No.
You can multiply by 5, and then you multiply the blue equation by 4. So you would get 20x and 20x.
Oh, so you can change both of them when you're eliminating.
So you're only going to aim for one or the other,
Okay.
right? Because if you try to eliminate both and you do, either something went wrong or stay tuned to find out what happened.
No, I mean like you can like change the equation by multiplying it by different things. Do that to
Exactly.
both.
Yes, right? Because remember, and that's why we can multiply by 2, we can divide by whatever, because an equation is a scale, it's a balance. Anybody use a balance in chemistry or biology or what are we teaching you kids these days, right?
Explosions.
Nothing.
Cool.
Yeah, nothing.
All right. But you guys have seen a balance before, right?
Yes.
Right? Balance, 2 sides equally balanced. It's okay if I add 5 pounds to one side if I do what? Add 5 pounds to the other side. They equal out. So here, it's okay if I double one side of the equation by multiplying by 2, so long as I did what?
Double the other side.
Double the other side.
Yeah, but never mind.
It's a
Never mind.
Okay. Okay. If there are lingering questions, don't worry. They may be answered by practice. Yay! All right. So we got 4 questions up there. So feel free to work together on these problems. If you want to work by yourselves, go for it. If you notice on the magical sideboard over there, I have 4 different colors. And notice that these problems here are 4 different colors.
Gotcha.
Put 2 and 2 together and we can just go through the floor, right? So we're not going to have a whole lot of time, it looks like, but do your best on these and we'll go over them, all right? What's up?